This tutorial is intended to discuss oxidation-reduction reactions on a biological standpoint rather than just purely chemical. Alright, so we've talked before about redox, oxidation reduction, being the exchange of electrons. Now, if we look at specifically biological systems, they focus on oxygen and hydrogen specifically rather than electrons. So no matter what, as we're looking at these, the oxidation and reduction will focus on the electrons. It just has the oxygen and hydrogen component added into it with biology, because that's more of a rule of thumb, not necessarily 100% of the time. But you see here with iron, oxygen's being added to it. And as a result, iron's going from a 0 to a +3. So it's losing electrons. Lose electrons oxidized. Just like with oxygen's being added, it's still being oxidized. So 100% of the time, if we keep track of the electrons, you will always get it right. However, there's a shorthand method that they use with biology. So oil rig is one way of saying it. Oxidation is the loss of electrons. Reduction is the gain of electrons. Once again, here we look at the Statue of Liberty, and we have copper, and oxygen has been added to the copper. And as a result, it's been oxidized. So when we added oxygen, it oxidized. In both cases, we added oxygen and it oxidized. So if we look at from the biology standpoint, from a strictly carbon-based organic observation, when we lose hydrogens, we're oxidizing, and when we gain oxygens, we're oxidizing. So here, CH methyl alcohol. We had 3 hydrogens here and 1 here, so we had a total of 4 hydrogens there to begin with. We actually lost hydrogens, so it went from 4 to 2 in that compound. When we lose hydrogens, it's oxidized. If we gain oxygen, so it's going from CO to CO2, we gained oxygen, it's being oxidized. So the rule of thumb is if you lose hydrogens or gain oxygens, you don't necessarily have to have that. That's going to be oxidized. If you gain hydrogens, notice it's the reverse. It was lose hydrogens, now we're gaining hydrogens. Or you lose oxygens, that's going to be your reduction. So 100% of the time, if you just follow the electrons like I've shown in previous tutorials, if you just follow the electrons, you'll get the answer 100% of the time. However, if you want to do the shorthand method, you probably have a 90% chance, 85% chance of getting it right still. And that's if we look at the adding of oxygen or losing the hydrogen for oxidation, or losing the oxygen, gaining the hydrogen for reduction. And that's looking at redox from the biological standpoint.